Welcome everybody here to this lecture. We're very excited to have Professor MacIntyre. Professor MacIntyre has written widely in philosophy since his first book, Marxism and Interpretation, appeared in 1953. He has taught at Oxford University, Princeton University, Brandeis University, Boston University, Wellesley College, Vanderbilt University, Duke University, and the University of Notre Dame. In 1989, he was a Luce visiting scholar at the Whitney Humanities Center of Yale University. He has also served as president of the Eastern Division of the American Philosophical Association. Professor MacIntyre is the author of over 30 books, including the influential works After Virtue, Whose Justice, Which Rationality, and 3 rival versions of Moral Inquiry. He has made prominent contributions to the history of philosophy, moral philosophy, political theory, philosophy of the social sciences, and philosophy of religion. In 2007, he published an examination of the philosophical work of Edith Stein set against the background of 20th century phenomenology, entitled Edith Stein, A Philosophical Prologue, as well as 2 volumes of his collected papers, The Tasks of Philosophy and Ethics and Politics. In 2011, he published God, Philosophy, Universities, A Selective History of the Catholic Philosophical Tradition. Although he retired from teaching in 2010, he remains housed at the Notre Dame Center for Ethics and Culture, where he continues to write and conduct research. He served as the center's first permanent research fellow. His talk today is entitled, What the Natural Sciences Do Not Explain. Please join me in welcoming Professor MacIntyre.
I begin with a rat, a particular rat, perhaps one of the rats used by Professor... Thank you. I'll begin again. I begin with a rat for the second time. A particular rat, perhaps one of the rats used by Professor Moshe Schief and his colleagues at McGill in their studies of the relationships between early maternal care and ability to cope with stress in later life. Mother rats, who devote themselves to licking and grooming their offspring in the first weeks after they are born, thereby trigger epigenetic mechanisms, so that a gene encodes a protein whose transmission sets up a feedback loop in the hippocampus. The result is a well-adjusted rat. Inject certain chemicals into such a rat, however, chemicals whose effect is to suppress the activity of the relevant gene, and the result is a rat liable to fear and anxiety. Consider now one such fearful and anxious rat, produced by injection in a laboratory, and ask what is the explanation of his fear and anxiety. The research scientists will tell you that what they have identified are the biological and biochemical causes of fearful and anxious behavior in rats. But interestingly, those biological and biochemical causes are insufficient to explain the fear and anxiety of this particular rat. For what brought about his fear and anxiety was the decision by some particular researcher to inject him with the relevant chemical. The efficient cause of his fear and anxiety was a human intention. That rat is the product of an intelligent designer. My reason for saying this is no more and no less than the facts of the matter about this particular rat's causal history. A history which begins with some thoughts of the researcher, an intention to implement a project that was part of a research program. When I speak of those thoughts as causes, whose effect was the fear and anxiety of this particular rat, I do not do so in virtue of there being some set of true law-like generalizations which connect researchers' intentions and experimental outcomes. There are no such generalizations. So the causal powers of those thoughtful agents who initiate changes in the natural world are not to be understood in such terms. How then are they to be understood? A first, and perhaps at first sight unhelpful step towards answering this question can be taken by thinking about thought. The philosopher whom we should consult is Plotinus, the greatest philosopher regularly omitted from the academic curriculum, partly to learn from him and partly to quarrel with him. What we need to learn from his fourth Aeneid is the crucial respect in which that which thinks, whatever it is, call it mind, call it soul, differs from a body. The unity of any particular body, the relationship in which its different parts stand to each other, is quite other than the unity of a mind or a soul, the relationship in which its various parts stand to each other. What bodies lack, and minds or souls possess, is a unity constituted by self-awareness. When I think, I cannot but be aware of myself thinking. The I that I use in my first-order thoughts, as when I ask myself, what should I conclude from that, has the same reference as the I that I use when I reflect on those thoughts, or as I'm doing now, reflect on my reflections on those thoughts. No physical body, no meson, molecule, or mountain has this self-awareness and capacity for self-reference. There are other characteristics of thought lacking in bodies. A thought can be incomplete, as an argument is incomplete, or a story is incomplete, or a plan is incomplete. And one and the same thought that is left incomplete today may be completed on some future day, or left forever incomplete. That is to say, we individuate thoughts and parts of thoughts using criteria very different from those that we use in individuating bodies and parts of bodies. I take Plotinus to be instructive on minds and souls, but seriously misleading about bodies, material beings, for he held that, I quote, matter does not mold itself to pattern or bring itself to life, while we know from recent scientific work that life and thought emerge from complex chemical reaction networks. More importantly for our present purposes, Plotinus's account of bodies, with its sharp Platonic contrasts between bodies and minds or souls, leaves it unclear how bodily movements could function as expressions of thought understood very much as Plotinus understood it. Yet it's in and through bodily movements that thought expresses itself and makes itself effective. It does so in two different ways, nicely distinguished by Fred Dretske. When we first set ourselves to learn to type, or to swim, or to shoot a layup, I quote from Dretske, we begin the learning process aware of the fingers, the arms, the legs, their positions and movements. Precisely timed sequences have to be coordinated. But when we become able to exercise these skills of coordination, the mind goes somewhere else. It is emptied of such performance details and concerns itself instead with the objectives or goals for which they are performed. So, in skilled activities, the bodily movements are what they are because the agent's thoughts concerning her or his goals are what they are, and because the agent's skills ensure that her or his bodily movements are such as to achieve those goals. Among those goals may be that of representation. Consider what is involved in a mime. Silently, a performer mimics the actions of someone bidding goodbye to a friend, waving as the friend departs. The performer conveys, by bodily movements, that she is not waving to someone, but imitating someone waving to someone. Her bodily movements are designed to function as complex signs, signs themselves designed to be interpretable in one way rather than another. The neurophysiology of those movements serves the purposes of thought, and it is the mimic as thinking agent who causes the movements to occur as they do and in the sequence in which they do. The mimic's thought is not only the efficient, but also the formal cause of those movements occurring as they do. Without reference to that thought, the occurrence of those movements as expressive and interpretable signs is in fact inexplicable, even if all the relevant neurophysiological and biochemical facts are known, even if all the physical facts are known. Of course, the bodily movements, the changing positions of arm and shoulder, are consistent with those facts. There are well-founded law-like generalizations, which connect the neurophysiological and biochemical antecedents of such movements with those movements. But there are no such generalizations connecting similar antecedents to episodes of well-planned mimicry, let alone episodes of well-planned mimicry designed to raise money from the spectators so that the mime can afford to visit her aging mother. It's difficult to imagine in any remotely realistic way what the content of such generalizations would be. If someone were to suggest that they are of the form, whenever such and such a set of neurophysiological and biochemical events occurs in someone's brain, then that someone acts out a mime in order to raise money, we should reply that the converse is certainly the case. That whenever someone acts out a mime in order to raise money, some neurophysiological and biochemical events are occurring in their brain. But what would be required to go beyond this, to the construction of the causal generalizations suggested by this objector, is wholly unclear. We know what it is for a set of thoughts to become or fail to become causally effective. We know what it is for there to be causal relationships between one set of neurophysiological and biochemical states and another. But what it would be for the causal efficaciousness of a set of thoughts to be explained in neurophysiological and biochemical terms, we have no idea. To this it will be said that the history of science provides many examples of phenomena for which no kind of natural scientific account could at one time be envisaged, but for which later conceptual and theoretical advances supplied explanations. There are no a priori grounds for taking something to be inexplicable by the natural sciences. This is, of course, true, but it's also true that there are no a priori grounds for taking something to be explicable by those sciences. The faith that the natural sciences in the very long run will explain everything about nature is just that, a faith. One widely shared these days by natural scientists and analytic philosophers, but no less of a faith for that. So that the reasonable way to proceed is perhaps to identify those characteristics of thought that, at least at first sight, make it unamenable to explanation by the natural sciences. But first, in order to avoid misunderstanding, let me characterize my own position a little further. Nothing in what I've said so far implies or suggests that anything that happens in nature is a happening contrary to the laws of nature as discovered by physicists and chemists. If something contrary to the laws of nature were to occur, it would be a miracle, and in this paper I'm not concerned with miracles. Moreover, I'm entirely open to the possibility that one day Alan Turing's hope and prediction will be realized and a machine constructed of which we can say, quite uncontroversially, that it thinks. But if the hardware and software of such a computer enable it to think, its thought will have the same characteristics as our thought. That is, there will be respects in which it and its effects will not be explicable in natural scientific terms. And that doesn't involve me in denying what it would be foolish to deny, that there are also features and aspects of thought which are indeed explicable in such terms. I began this paper by thinking about fearful and anxious rats, whose fear and anxiety are to be explained in part by their genetic inheritance, in part by their biochemical makeup. But there are, of course, fearful and anxious human beings prone to fearful and anxious thoughts. And I've no doubt that this aspect of their thoughts is explicable by their genetic inheritance and their biochemical makeup. What, then, are the features and aspects of thought which are not so explicable? Consider first the power of thought to make discoveries, the articulation of thoughts that involve radically new concepts. On October the 16th, 1843, William Rowan Hamilton was walking with his wife by the Royal Canal in Dublin when he hit on the idea of quaternions. Hamilton's problem had been that of how to represent complex numbers as points in three-dimensional space. The coordinates of such points are triples of numbers, and while Hamilton knew how to add and subtract triples, he had found no way of multiplying them. But on that day, as he wrote the very next day to John Graves, there dawned on me the notion that we must admit in some sense a fourth dimension of space for the purpose of calculating with triples. And a formula for so multiplying presented itself to him, a formula that he immediately scratched on the stonework of the next bridge over the canal. A quaternion is a quadruple that can be so multiplied. Karl Popper argued that such conceptual discoveries must be unpredictable. For were someone to be able to predict such a discovery, they would have to be able to say what it was that was going to be discovered, but in order to do that, they would have to have already made the discovery. We can and should go one step further than Popper. Not only is it the case that we can conceive of no generalization formulable before the event of discovery on which we could rely in predicting that event, there are just no plausible generalizations formulable after such events, specifying antecedent conditions such that, were they satisfied, that particular event of discovery would occur. There are many aspects of scientific discovery and invention that we are well able to explain. Why under certain conditions this style of thinking will tend to flourish and that not. Why under certain conditions, those of Bell Labs, for example, scientific research is more likely to be productive. Why, if you educate children in certain ways, they will be more likely to become imaginative scientists. But none of this takes us a step nearer to explaining the kind of radical conceptual innovation that enables science to move in new and unpredictable directions. Thought has the power to be, in a very special way, an agency of change. But what does it change? Someone's knee every day goes through the same sequence of movements several times over. What is involved in those knees moving as they do? There is a story to be told about those knees as a mechanical system, a story about muscles, tendons, and bones. There is a neurological story to be told, a biochemical story to be told, and even a story about elementary particles. But none of these stories explain why these particular knees are repeating this particular sequence at this particular time and place. What does explain this? They are the knees of a ballerina who, in the course of rehearsing her part in Swan Lake, is representing the movements of a dying swan, as choreographed by the latest of a long line of choreographers. Unlike the mime in my earlier example, she's not imitating a dying swan. She is, together with others, enacting a narrative. Her thought has been translated into bodily movement in just the way that Gretzky described, but the thought so translated is not only her thought, and this in two respects. What she reproduces in moving her knees is a conception of how her role is to be danced that was first elaborated in St. Petersburg in 1895. And her movements would not have the expressive function that they have were it not for the movements of the other dancers that enable her movements to be interpreted as they are. Thought, informing her bodily movements, provides them both with their formal and their final cause. Consider two other pairs of knees, by coincidence going through precisely the same sequence of movements as those of the ballerina, for, say, 15 seconds. One set of knees is that of a soccer player who's just been tackled and who is involuntarily falling towards the ground. The other is that of someone in an exercise program designed to develop his muscle strength. Three more or less identical muscular and nervous sequences have quite different explanations in quite different trains of thought. Someone may at this point remark that the thought of which I've been speaking in my various examples is always embodied thought, and so it is. When Hamilton described his experience in his letter to Graves, he wrote that an electrical circuit seemed to close and a spark flashed forth, metaphors that suggest a change in Hamilton's brain, a change that we would describe in neurological terms. But what made that change significant was the thought that emerged. And if the embodiment of that thought was that neurological change, then that change was what it was because the thought was what it was. The relevant antecedents of that thought were not events in Hamilton's brain, but a sequence of mathematical questions and answers framed by Hamilton in previous hours and days and years. I don't mean by this that the immediate neurological antecedents of the thought play no part in explaining why Hamilton had his thought just at the moment that he did, but they don't explain why he had that thought. Only his antecedent mathematical inquiries do that. Consider now yet another characteristic of thought exemplified by, among others, London taxi drivers. London taxi drivers, in order to be licensed, have to pass an examination showing that they have a comprehensive knowledge of streets, routes, and addresses within a 6-mile radius of Charing Cross. It takes up to 3 years to acquire what taxi drivers call the knowledge, and about 3/4 of those who set out to acquire it become discouraged and drop out. Those who stay the course get 2 things: a taxi license and a hippocampus notably enlarged at the back and somewhat smaller at the front. The hippocampus is a part of the brain that in birds and other non-human species is associated with navigation. In those acquiring the knowledge, the change is gradual. The longer they've been at it, the greater the change, as Eleanor Maguire and our colleagues at University College London discovered. Imagine would-be taxi drivers setting themselves to memorize one of the more difficult routes, say Chelsea to Tower Hamlets Town Hall. By thinking their way through the route, street by street, again and again, they become able to drive it without much explicit thought, and incidentally and unintentionally, they produce changes in the hippocampus, and therefore changes in the fundamental particles of which the hippocampus is composed. We can formulate something very like a law-like generalization to the effect that the longer anyone studies to be a London taxi driver or engages in some relevantly similar thoughtful task, the larger the rear part of their hippocampus will become. And from this generalization, we can draw causal inferences. But notice the direction of the causality, from the student taxi driver's thoughts as causes to the changes in their hippocampi and in the particles composing their hippocampi as effects, and not vice versa. Other examples of the same causal direction are instructive. An experimenter in a physics lab directs a light source so that the light passes through a piece of Polaroid, that is, a thin film of nitrocellulose with extremely small crystals, with the result that the light is plane polarized. What made it the case that this particular ray of light was polarized? We can identify the physical conditions that had to be in place for this to happen. But what ensured that those conditions were satisfied was the decision of the physicist to conduct this experiment at this time and place. The polarization was the effect of the physicist's thought. Compare now another experiment, one in which photons are made to strike calcium atoms in an excited state, so that those atoms emit photons of the same energy. The experimenter intends this effect, but she does so because she is, for instructional purposes, replicating part of the experiment by Friedmann and Clauser, which first showed decisively that Einstein's appeal to hidden variables in his critique of quantum mechanics was mistaken. This experimenter is staging a piece of theatre, reenacting a dramatic moment in the history of physics, just as the ballerina was reenacting the choreographer's conception of the dying swan. It was Martin Ager, that great teacher of physics, who suggested that it can almost be said that a new experiment is designed to be performed again and again as a dramatic play. When it is repeated, as our imagined experimenter repeated the experiment of Friedmann and Clauser, the physicist contrives that atoms and photons replicate those earlier atoms and photons, so that they change as they do can't be explained except in terms of the experimenter's dramatic intentions. Far from it being the case that the experimenter's thoughts are to be explained by referring to events in the realm of elementary particles, some occurrences in the realm of elementary particles can only be explained by referring to complex sequences of thought. In saying this, I am not only ascribing independent causal powers to thought, I am also putting myself at odds with the widely held view that it is in the realm of quantum fields and elementary particles, or perhaps of multidimensional strings, that all explanation terminates. Here, although most physicists and many philosophers treat this thesis as beyond question, I do have support from within the natural sciences. Robert Laughlin, in, for example, his Nobel Prize lecture, has argued that superconductivity cannot be explained in terms of quantum mechanics. It is an emergent property. I take him to be saying that we can only explain how electrons behave in metals that are superconductors as the effect on them of the metallic lattice, so that electrons that would otherwise repel each other attract. The emergent properties of superconductors are not to be explained by, cannot be deduced from, the properties of the types of particle that compose them. Explanation terminates in more than one place. Stuart Kauffman has argued similarly that organized systems capable of self-reproduction and thermodynamic work cycles produce chemical reactions that change the history of the molecules that compose them. The causal chain in such cases runs from the organism to the molecule and the particles that compose it, and not vice versa. But of course, nothing in either Laughlin's or Kauffman's views suggest anything like my claims about the independent causal powers of embodied thought. Those claims, as I've already suggested, aren't in the least inconsistent with a recognition of how many aspects of thought are open to explanation neurologically, biochemically, and perhaps in the end, quantum mechanically. Part of the interest in explaining genetically and biochemically why some rats and not others are prone to fearfulness and anxiety is that this is a prologue to explaining genetically and biochemically why we humans similarly are prone to fearful and anxious thoughts. Such explanations are unproblematic, and so are many others. We may indeed be able to explain in just those terms why and how certain traits important to thought, an aptitude for abstract reasoning, say, or intellectual perseverance, are in some cases genetically transmitted, and in others not. We can already explain, and will most certainly explain better, the effects of aging upon thought and those disturbances of thought that are the result either of injury to the brain or of schizophrenia. We will be able to identify much better than we can now the neurological and biochemical conditions necessary for thought of various kinds to occur. And of course, it was evolution by natural selection that formed human beings so that they first acquired the ability to inquire. What can't be so explained are some of the subsequent courses taken by the inquiries that then developed. The inquiries of directed, norm-governed thought, thought informed by the goals of describing, understanding, and evaluating, thought that is question-answering and problem-solving, thought whose initial questions are, what is this? How is this to be understood and explained? And what is the good of doing this rather than that? Embodied thought, that is to say, is by its nature goal-directed, has a teleological structure. The ends to which it is directed are both theoretical and practical. It takes as its good not only the furnishing of answers to the questions that I just catalogued, but the achievement in practice and production of the goods identified in those answers. It has two other important properties. Because each individual's thought begins from the particularities of her or his individual experience, it has a history that is its own. It has the marks of her or his past and present time, place, and circumstance. But because each individual learns to think from others and develops her or his thought with others, our thoughts also have a social dimension. We participate in and contribute to goal-directed enterprises of embodied thought that were initiated often long before we were born and that will continue long after we're dead, as Hamilton's discovery of quaternions contributed to and transformed the history of mechanics, and as both Prometheus and Fanny Farmer contributed to the history of cooking. Embodied thought, the thought expressed by and through human bodies, thus becomes embodied in two other ways. It finds expression in those institutions and organizations through which the enterprises of thought are carried on, and it finds expression in those artifacts that extend the power of hand and brain. So the invention of democracy by Cleisthenes and the invention of the steam engine by Wyatt are as much moments in the history of thought as the discovery of quaternions by Hamilton, and are for the same reason not explicable by the natural sciences. It must by now be clear that if my overall argument is sound, then among the items that are not open to explanation by the various natural sciences, we have to include the courses taken in their history by those same natural sciences. The history of natural science will never itself become a natural science, and a being who at the time of the Big Bang was omniscient in this sense, that it knew all the facts about fields and particles, and all the laws governing fields and particles, could not have predicted the emergence of the natural sciences. It follows that, insofar as the structure of the physical universe has been affected by technologies that are applications of those sciences, that structure, too, cannot be wholly explained in natural scientific terms. But at this point, we have to be aware of another possible mistake, that of supposing that what can't be understood in natural scientific terms can't be understood. There are, in fact, distinctive modes of historical and sociological understanding. Consider an example of the latter drawn from the theory of organizations. Half a century ago, Tom Burns provided strong evidence that innovation is much more likely to occur in organizations in which management is decentralized and in which information flows freely in different directions than it is in organizations which are strongly controlled from the center. Where there is openness to innovation, we find the continual redefinition of individual tasks and the transmission of information and advice rather than of detailed instructions, so that flexible responses to new information are possible and the multiplication of centers of problem solving and decision making occurs. These hypotheses were strikingly confirmed by Burns's later studies of organizations such as the British Broadcasting Corporation. The generalizations that he formulated are not law-like. They are what Aristotle called hos epitop pollu generalizations, generalizations that hold characteristically and for the most part. The falsification of such generalizations is a more complex matter than the falsification of the law-like generalizations of the natural sciences, but they are genuinely explanatory. They explain why certain kinds of organization produce regimented and predictable minds. They allow us to predict predictability and unpredictability. They enable us to identify the kind of managerial and administrative thinking that is bad for thinking, a very different kind of cause of bad thinking than that which results from brain tumors. What I've been presenting is a view of the universe as irreducibly messy. There are different kinds of cause and effect relation, and no single conception of causality will do them justice. Causal chains move in different directions. There are explanations of different kinds that terminate at different points. There are causal agents of very different kinds. If this is so, and it needs considerably more philosophical work than I've even hinted at here to show that it's so, then we have to reject some ambitious philosophical programs, most notably that of physicalism in any of its versions. All physicalists hold that the world is what physics tells us that it is, or rather what physics is in the end, whatever that is, going to tell us that it is, and that all truths are what they are only because the truths of physics are what they are. Reductive physicalists, such as Alex Rosenberg, take it that the answers to all answerable questions are or will be supplied by physics, chemistry, and molecular and evolutionary biology. Non-reductive physicalists allow that we have and need different types of vocabulary and theory to describe and understand aspects of our activity and experience. But everything so described and understood is what it is only because physical reality is what it is. For them, as for reductive physicalists, physics is in some sense the science of everything. And just this, of course, is what I'm denying. But now consider a problem posed for my position. How are those various types of explanation that I have begun to catalogue related to each other, when more than one of them is required to account for some sequence of actions or happenings? We've already noticed such cases, those, for example, of the movements of the ballerina's knees, movements that need to be explained both by the physics of moving bodies and by the ballerina's complex intentions. But this is only one instance of a problem that arises with all well-functioning agents, and that becomes more acute with complex intelligent agents, such as mice, dolphins, wolves, elephants, and ourselves. What is it to be a well-functioning agent, a well-functioning mouse, elephant, or human? Evolutionary theory will not help us here. It has a well-confirmed and impressive story to tell us about how genes, cells, and unicellular and multicellular organisms played their part in bringing it about, but there are such well-functioning agents as mice, elephants, and humans. But our understanding of what it is to be a well-functioning agent is prior to and independent of that explanatory story. And our understanding of what it is to be such an agent is indispensable both to our scientific and other inquiries and to our engagements with each other in the transactions of everyday life. It's indispensable to the latter because how we respond to the failures of others to function well depend upon what we take the explanation of those failures to be. Consider 3 examples of such failure in humans. There are, for example, those suffering from anarchic hand syndrome, who find that one of their hands distressingly performs goal-directed actions, such as snatching food from somebody else's plate at dinner, that they didn't intend and can't suppress or control except by grabbing that hand with the other hand. The explanation is neurological, not a failure in etiquette, and we excuse it accordingly. The agent's normal functioning has been disrupted by something not the agent, causing neurological damage. Contrast someone who keeps failing to turn up for appointments, so disrupting both his and others' lives. It may be that this forgetfulness is due to normal aging and to resulting changes in the brain. But often for such failures there are remedies, ways of making sure that one is reminded in good time. When this is the case, we no longer excuse the agent's forgetfulness, even though it too has a neurological explanation. We blame the agent for not developing countervailing habits. And so we do too in a third type of example, where the agent's failure is due to willful acquisitiveness, say, that is, to a failure to acquire the virtues of temperateness and justice to the degree that is required for functioning well with a human agent, a failure in habituation. What these responses to failure to function well exemplify is a mode of explanation so familiar to us that we're often unaware that we're employing it. If asked concerning any well-functioning agent, why it's acting as it does, when its actions are those characteristic of a well-functioning agent at this stage in the development of its powers and in this type of situation, we reply that it's so acting because the agent is the kind of agent that it is, and this whatever the extent of its powers of thought, whether it's a human being, a mouse, an elephant, a dolphin, a wolf. It's when such agents are malfunctioning that we advance causal explanations as to why some conditions necessary for their well-functioning have not been satisfied. The difference with human beings is only that their powers of thought are such that they are able to provide remedies for their malfunctioning more often than mice and elephants are. Mice too can undergo biochemical changes that make them forgetful. Young male elephants deprived of role models become delinquent just as young male humans do. But neither mice nor elephants have the resources to remedy their condition that humans possess. I've said that this mode of explanation is also indispensable in some of our scientific inquiries. If we want to understand mice, dolphins, wolves, elephants, or human beings, we have to be able to distinguish those individuals and groups that are functioning well at various stages in the development and exercise of their powers from those that are injured, diseased, stunted in their development, or abnormal in some other way. For members of such species to function well is, of course, for them to function well in their social relationships. And so we have from the beginning to be concerned with their forms of social life. When in the case of some set of well-functioning agents, we ask why those forms of social life are what we observe them to be, we reply once again that it's because these agents are the kind of agent they are. Once again, it's only when they are malfunctioning that we advance causal explanations as to why some neurophysical or neurophysiological or biochemical or other condition necessary for their well-being has not been satisfied. Return now to the ballerina's knees. When she's functioning well as a fully trained ballerina in a well-functioning ballet company, we explain the movement of those knees by citing the choreography and the skills that she exercises in dancing as the choreography requires. It's when her dancing is defective in some way that we advance causal explanations, anatomical, physiological, neurological, of why some necessary condition for her knees to move as the choreography requires has not been satisfied. The questions that we pose, either using or presupposing application for the concept of a well-functioning agent, are of more than one kind. We need to identify and understand in detail what it is for a mouse, an elephant, or a human being to develop its distinctive powers, including the powers of embodied thought, successfully or unsuccessfully in different natural and social environments. We need to supply the history by which particular individuals or groups of individuals came to be in the state that they are in now. We need to identify those normative structures and goal-directed activities that characterize the social lives of members of different species, the territorial norms, for example, of birds and wolves, as well as those of humans, the goal-directed activities of dolphins and elephants, as well as those of humans. In all these inquiries, we'll find ourselves making use of a variety of empirical findings, some from the natural sciences, from neurology, biochemistry, evolutionary and molecular biology, some from the social sciences, from sociology or anthropology. But this shouldn't be allowed to conceal from us the extent to which the form of our inquiries is Aristotelian. For we will find ourselves committed to distinguishing between the essential and the accidental properties of members of the kinds that we are studying, between what individuals of those kinds at any particular stage are and what they have it in them to become by reason of their specific nature. That is, between their potentialities and their actualities, between the matter of which they are composed and the structure that gives form to that matter, between those individuals who achieve the ends that complete the life of such an agent and those who do not. We will be inquiring as to formal, material, efficient, and final causes. Many of those engaged in such inquiries, many students of animal behavior, for example, will not, of course, recognize themselves as Aristotelians. Nonetheless, their inquiries are Aristotelian inquiries, and the explanations that they supply have a peculiar importance among the various kinds of explanation that we need, just because they are indispensable to our understanding of ourselves as embodied thinkers, animals who, as rational animals, reflect on the relationship of rationality to animality. Many of Aristotle's and of subsequent Aristotelian answers will not, of course, do. Some of Aristotle's questions and their presuppositions retain all their importance. I am then in this paper making three central claims, all of them argued for far too briefly. The first concerns the distinctive powers of thought and the nature of explanations that terminate by citing some exercise of the powers of embodied thought. The second is a more general thesis about the range and variety of different types of causal connection that we need to identify and of different types of explanation and understanding that we need to make use of. The third takes note of one particular class of explanations of human and other animal activity that turns out to be indispensable, those that make use of the concept of a well-functioning agent, and that are Aristotelian in the concepts that they employ and in their analytic and argumentative structure. All three entail a rejection of physicalism in any of its forms, but they have nothing in common with two other notable rejections of physicalism. Intelligent design theorists argue that there are some particular phenomena too complex or too improbable to be explained by the natural sciences. This is not at all what I take to be the case. The only intelligent designers whose activities explain what is not otherwise explained are, in my view, intelligent animals. Moreover, I don't share the view expressed in Mind and Cosmos by Thomas Nagel, that an adequate account of nature will be one that shows, I quote, how the natural order is disposed to generate beings capable of comprehending it. On the contrary, all that we now know seems to show that given the early physical history of the cosmos, the emergence of life was an incidental and accidental outcome of contingency and chance, and that given the course of evolution by natural selection, as we now understand it, the emergence of well-functioning rational agents was also an incidental and accidental outcome of contingency and chance. It could very easily have been otherwise. There seems to be a much less straightforward all-of-a-piece universe. Ours seems to be a much less straightforward all-of-a-piece universe than either Aristotelians once supposed or than physicalists now suppose. Ancient and medieval Aristotelians, rightly impressed by the teleologies of the human and animal world, mistakenly attempted to explain even the basic workings of the physical constituents of the universe in teleological terms. Modern physicalists, rightly impressed by the explanations advanced by quantum mechanics, relativity theory, and string theory, mistakenly aspire to explain norm-governed and goal-directed activities in physical terms. Both were and are misled by having a view of how things must be explained and understood, rather than of how they are in fact explained and understood. Both had and have too restricted and impoverished a view of what causality is, what explanation is, what nature is. Both provide imaginative descriptions of possible worlds rather than accurate descriptions of the actual world. There is therefore an interesting metaphysical question. Why is the actual world this world rather than either a physicalist or an Aristotelian world? What accounts for the contingencies falling out in this astonishing way, so that we begin with quantum fields and the particles that are the quanta of those fields, and we end with dolphins and wolves, Aristotelians and physicalists? One answer to these questions is that there's nothing to account for. The universe that we inhabit is one in an infinite set of universes in which every possibility is realized. But if we reject that answer, as I believe that we should, we can't escape our metaphysical question. There's also, of course, an interesting metametaphysical question. Is this metaphysical question a legitimate question, an answerable question? If it is, then certain answers to it can be ruled out immediately. The explanation of why this world is the actual world can't be given by citing some agent that exists in and as part of this world, for any such agent is among the items that needs to be explained. And every particular finite agent that happens to exist in and as part of this world. So the only explanation that could be given would have to cite some agent that does not exist in and as part of this world, that is not one more finite particular, an agent, therefore, that differs from such particulars, not just contingently, but necessarily. If we reflect further on how such an agent would have to be characterized, we will quite soon reach the point at which Aquinas made a remark about what he took to be common linguistic usage. This, he says, we call God. But suppose that we had never heard even rumors of God, that we had no previous use for the name God. We should still be committed to holding that if the metaphysical question is legitimate and answerable, and here further argument is indeed required, then it can only be answered by inferring the existence of just such an agent. We might then proceed to inquire, just as Aquinas did, what that agent's further attributes must be. But unlike Aquinas, we should be able to conclude at once that, given the nature of his universe, he must be neither an Aristotelian nor a physicalist.
Thank you very much. We have about 30 minutes for questions. There's 2 microphones in the balcony and 2 down here, so please come to the microphones, introduce yourself, and let's begin over here.
My name is Mike Jones. I have a question based on medical history. If you're familiar with the disease, the venereal disease, syphilis, there's a tertiary stage of syphilis, which can either go to the abdomen or to the brain. When syphilis goes to the brain, it has certain consequences in terms of thought. One of them is delusions of grandeur. which was recognized by the medical history. Now, the question that and there are other people who have seen various literary figures in history who have had syphilis. For example, Nietzsche, or maybe less probable, Beethoven, the Ninth Symphony, more probable, Bram Stoker, especially his book, The Lair of the White Worm. The question I have for you in terms of causality is, to what would you say that syphilis caused thought, that syphilis caused a particular kind of thought? In other words, did the brain, obviously a malfunction of the brain, but did the brain cause a particular kind of thought?
Well, let's be clear about the kind of evidence that we have. The evidence we have is that some people who have exhibited rather striking gifts of thought, aesthetically, or in Nietzsche's case, if you like, prophetically, this may be the result of syphilis affecting the brain. It's very important that it isn't just that the brain is affected, but these are in an important way distortions of thought as it would otherwise be. So this is like, it's more striking often enough, but it's very like what I was talking about in the person who is very fearful and anxious. Somebody who is very fearful and anxious will have a great deal of their thinking affected by it. They will continually be looking around themselves for dangers. They will be continually trying to guard off things that are making them anxious. And so the rest of their thought will not proceed as it would otherwise have done. And that you can therefore interfere with thought by affecting the brain is absolutely clear. There's no problem about that at all. What I'm saying is something quite different, namely that we have no evidence whatsoever, I don't even, I think, really understand the suggestion that it is in the antecedent conditions of the brain, the neurophysiological and biochemical antecedents, that we can find the conditions which would explain such things as Hamilton's thoughts about quaternions, or indeed a great deal of routine scientific thought or other thought of this kind.
Melissa.
Melissa Muscella from Catholic University. I just wanted to ask, following up on your comment about intelligent design theories, and this is a friendly comment. I agree with your criticisms and reservations of that theory, but I think one of the reasons why that theory is powerful or attractive to many people is that the idea that we came about through chance and completely contingent causality just doesn't seem to fit, particularly with an overall Judeo-Christian or even any sort of theological worldview with the idea of a rational plan of a creator that cares about us. And so I was wondering if you might elaborate a little bit more about another level of causality, another distinction in causality, which you alluded to at the very end of your presentation, the distinction between primary causality and secondary causality, and how recognition that there's causality happening at another level beyond and explaining, quote unquote, the level of contingency, guiding the level of contingency, can help us to see how contingency and providence are compatible.
All that I said about intelligent design theory was that I do not think it the case. I'm not suggesting that there are certain phenomena in nature which are either too complex to be explained or too improbable to be explained. And both attempts to show this seem to me to have failed, must fail. If people find it extraordinary that they should have been produced by contingency and chance, they're quite right. I mean, yes, how odd. And it is very, very odd indeed. I mean, that is extraordinary. I mean, it would be much less extraordinary if, in fact, we turned out to have been designed by, so to speak, a cosmic maker of breakfast cereals to be given away. You know, I mean, that is, if it all followed, that would be much less extraordinary. So it is very extraordinary. The account of nature which I'm proposing, the ways in which we think about nature, the argument hasn't at any point here, I mean, I did make my joke at the end about God, but it was a joke, and there are no necessary theological implications. Somebody could believe everything that I have asserted here and not believe in God. On the other hand, if you are a theologian, I think you would be able to come to terms fairly easily with this account of nature in a way that you wouldn't have been able to come to terms either with a physicalist view or with a thoroughgoing Aristotelian view. So I think this view is entirely consistent with Jewish or Christian theology or Islamic theology, but I don't think that it necessarily commits anyone to something like this. It's not, my view is not that different from the view taken by my former colleague Abner Shimoni, a very notable particle physicist, whose book of essays is called Towards a Naturalistic Worldview, but who insists that mind has certain distinctive features, and what he's talking about as mind is what I'm talking about as thought, which simply can't be reduced to other terms. And I'm arguing that there's more here than just resisting reductionism.
Can I just follow up briefly? I didn't mean to imply that your view requires or implies in any way a particular theological perspective. What I was getting at more was how your view might be compatible with a strong sense of providence as guiding even the so-called contingent causal processes that got us here. In other words, is there room for the real action of providence in your story?
Yes. I mean, that's really what I want to say.
In Aquinas theology, St. Thomas here. Okay.
I see.
In Aquinas theology, it is stated that God is not only being itself, but existence itself, the uncaused cause. Would you say God is thought itself, the unthought thought? I mean, like God is the source of all thought, or?
No, I wouldn't.
Okay, thank you.
Simply because of the notion, I mean, for this reason, I mean, you might want to spell this out further so I could make sense of it, but unthought thought at the moment has no sense for me.
Okay, I mean...
I think that the God of Jewish, Christian, Islamic theism is a God who is the author of everything, right?
Yes.
He is the first cause, and every other cause in the universe is secondary to his primary causality.
Yes.
All that I'm perfectly happy to affirm as part of theology.
Could you repeat that again? I mean, the last sentence I'm a little hard at hearing.
But all other causes in the universe are secondary causes willed by God as first cause. This doesn't mean they aren't real causes. Aquinas takes a lot of trouble to insist that they are, in fact, real and effective causes, and that their reality as causes is not in the least diminished by the fact that God wills them to be causes.
Thank you.
Over here.
I'm John Geeson from University of St. Thomas. I was just wondering, simple question, what's the difference between normal and what is good? For example, a good nose smells, and that is because a nose normally smells. Thank you.
There's a very close connection, and they're certainly not the same. So let me try to say something that is useful, but will certainly not be long enough. Suppose I set out to study a wolf pack or a herd of dolphins, or whatever it is. One of the things that I will do is to study a number of such packs first and a number of herds in order to discover what seems to be normal. And I will begin with certain generalizations about normal behavior. And it's only after I've discovered that I'm actually dealing with normal behavior for this kind of species that I'll be able to ask, to what goals are they directed? If, for example, this is a wolf pack or a herd of dolphins that has been ravaged by disease, then it may well be the case that their abnormal behavior will be such that if I study them, I will be unable to identify what it is that wolves grey wolves are pursuing as goals, or that dolphins grey dolphins are pursuing as goals. So the distinction between the normal. But here again, the normal is not merely what turns out to be statistically usual in what we study, but what is statistically usual in a group which is, as far as we can tell, not ravaged by disease or affected by malnutrition or whatever. And so there's a certain circularity in the reasoning here. We go to and fro. I hope this begins to help. What I'm arguing is that it's only when we know what normal members of a species are like that we can ask questions about the kinds of goods to which they are directed qua members of that species. This is the sort of connection we're trying to identify.
So my name is Michael. I'm from here at the university. I have a question regarding teleology. You used teleology as a common ground to compare modern physicists to ancient and medieval Aristotelians. And I think I remembered you saying something about Aristotelians being too concerned with teleology or something. And so my question is, do you view modern physicists as very concerned with teleology, like what the end of the universe is, and Aristotelians as very, like, who is concerned and who isn't, and should they be and shouldn't they be?
Yeah, I'm sorry wasn't clear. What I argued was that, in fact, basic physico-chemical understanding of the universe has no room for teleological notions at all, period. I also want to argue that the moment you start dealing with self-organizing systems, systems that sustain themselves in being, systems that function well or badly, teleological notions are indispensable. It therefore follows that there is a crucial difference between the way in which we deal with purely physical phenomena, where we're not going to find teleology at all, and cases where we deal with self-organizing systems of various kinds, notably systems that are animals, various kinds, and where not paying attention to teleology is going to mislead us. It's when we come to the cases where these two come together that we get interesting questions as to how we fit the two kinds of explanation together, and that's what I was talking about all too briefly in the latter part of the paper.
Great, thank you.
William Stegall from Medical City Children's in Dallas and the University of Dallas. Your talk is entitled What the Natural Sciences Do Not Explain. And so my question is, can you give us a brief explanation of what the nature and limits then are of natural science? Because you seem to have intertwined natural science with the material cause throughout your paper, but shouldn't it be biologists who tell us what a good frog is? Your notions there between norms and goods earlier, it should just be natural scientists who tell us what are the norms and what are the fitting behaviors of their subjects.
First of all, about my title. It wasn't a good title, and I thought about revising it, and all the revisions I thought of were worse than the original. Forget the title. Secondly, it would be nice if what you said about biologists was always true, but it ain't. And I'll give you a very striking example. I was involved quite a lot in the dolphin studies at one stage in my career. A lot of my thinking here stems from that. Modern dolphin studies actually took their great leap forward from a purely accidental meeting between a very distinguished biologist and a dolphin trainer. And it turned out that up to this point, these two hadn't interacted at all. The biologists had their account of dolphins, dolphin trainers had their professional expertise. And it was when they got together that they began to understand what was going on. That dolphin trainers had a much better idea than biologists did of what it was that dolphins were aiming at, of what it was that frustrated them when they were in captivity, for example, of the way in which they dealt with and responded to frustrations. You can go on characterizing these interesting things, in which they exhibit very remarkable intelligence. What the biologists understood were the mechanisms that enabled dolphins to respond in this way, and what those mechanisms were, which when damaged or distorted, led them to be unable to cope in various ways. So when you put together these two, you then quite suddenly got a real leap forward. Now, what the dolphin trainers supplied, I mean, call it science if you like, or don't call it science. We don't normally think of dolphin trainers as a kind of scientists, but very good ones understand a great deal about species. And so it is too with other animal species. I mean, the discoveries that people have made about elephants, a very striking disease discussed, have only been made by people who've, as it were, lived with elephant herds in the same way as which anthropologists live with societies they study, and discovered what it is that elephants do. Once again, what no amount of that kind of study will tell you is what the biochemistry and neurophysiology involved is, and its parallels to and differences from the human. So what I'm wanting, in many phenomena, we're adding explanations from different places. The crucial thing is to recognize the need for a multiplicity of types of explanation and understanding.
My concern is if you say that it's proper to natural science to only deal with the material cause, then the material cause will not be able to get you to final causes. And so if you can't have is's giving you oughts, then that's a real problem. So is it defective natural science where the dolphin biologist can't tell you what a good dolphin looks like? Or is it proper natural science and you need multiple expertise?
Well, it's extremely important that no amount of information about the mechanisms that are operating in a dolphin or an elephant or in us will give you an account of final causes. And the notion that if only we had something that, in your terms, would seem to be an adequate physics, it would somehow point us, it doesn't point us towards final causes at all. The people in the 16th and 17th centuries who got rid of Aristotelianism were basically right in thinking that so long as they were to understand the universe in terms of physics and later of chemistry in this way, there's no space for teleology. Teleology comes in quite another way.
I'm Andrew Lind. I'm a seminarian for the Archdiocese of Milwaukee. Can you hear me?
Yes.
I'll just hold it. I'm Andrew Lind. I'm a seminarian for the Archdiocese of Milwaukee. My question also has to do with teleology, but mine is more specific. If I understood you correctly, Dr. MacIntyre, you said that embodied thought is necessarily teleological.
Yeah.
My immediate thought was, does that mean that all thought is teleological, or does it mean that we can have thoughts apart from our body that are not necessarily teleological?
I made it quite clear when I talked about thought as an agent in nature, which is what I was talking about. It's embodied thought I'm talking about. So I wasn't talking at any point about disembodied thought. That's the first point. Now, in what is it that marks thought as being teleological? Well, we start thinking, we are confronted, I mean, crucially, we're confronted by questions. And the moment we're confronted by questions, we have to ask, what would it be to think our way through these questions and to answer them, and for the sake of what are we trying to answer them? And I think these teleological presuppositions inform a great deal of thought that doesn't at first sight look teleological. Now, of course, there's plenty of things that are just, as we say, idle thoughts. All sorts of things pass through our minds. I'm not suggesting that these are teleologically informed. These are, in fact, typical distractions. So if you want the paradigm of thought, it is of the student sitting down to write a paper and keeping thinking about something else, a not unknown phenomenon. But there is, I mean, thought sets itself tasks, and the tasks are, as it were, internal. Not as it were, the tasks are internal to the thought.
Thank you.
Thank you, Professor MacIntyre, for your lecture. My name is Nick Ogle. I live at the Catholic Worker House here in South Bend. My question concerns technology and natural science. And we find ourselves in a time when natural science finds itself subjected to the demands imposed by technology. In After Virtue, you ask the question, Aristotle or Nietzsche, as Nietzsche rejecting rationality ultimately, or teleology. That's my understanding. And I'm wondering if that rationality gets played out in the reduction of natural science or reduction of human life to physics, and also how a life lived now embedded with technology, which removes us from space and time in a particular way, and it is devoid of signs, which you say make actions intelligible. Actions are intelligible by their appearance or occurrence within a social setting. And I wonder, what connection do you see between the introduction of technology in the 21st century and the fruit of natural science or lack thereof?
Well, look, let me just say two or three things that may be relevant. I'm not quite clear what the question is. That, first of all, good scientific research tends to be conducted very interesting scientific research tends to be conducted in institutions where there is not too preconceived an idea of what the outcome is to be. So if you look at Bell Labs in the period in which it flourished, or if you look at the way in which the United States Navy used long ago to finance research, you simply take very intelligent people with lots of ideas and you set them down and you say, get on with it. And you don't know what's going to come out. And that's stage one. And this is how all sorts of very interesting things are learned. The next question is, what are you going to do about these discoveries? Which ones are you going to develop technologically and which aren't you? And here there's a mistake, and this has nothing to do with anything I've been talking about heretofore. The mistake is to suppose that, in fact, we don't have choices that we do, in fact, have. So let's take an interesting example. In the 1950s and 60s, 70s, not after that, in both Zambia, in Africa, and in China, the thought was strongly entertained that perhaps as the society developed, it should not take up the automobile as a mode of transport. They would use trucks for transportation of various sorts. They would use perhaps buses, but the individual automobile would not be used. How would people get around? They would use bicycles. And both Kenneth Kaunda in Zambia and some Chinese leaders seriously envisaged the possibility of a society where you didn't go after the automobile. Now, in the end, that didn't happen. It's very important to look at why it didn't happen. But for a moment there, people did actually recognize that they had choices which we don't normally think of as having choices. We don't have to have laptops. We don't have to have many of the phenomena of information technology. And it is a healthy Luddite thought that from time to time what you need to do with the technology is destroy it, get rid of it in various ways. But then the question is, which of the technologies are the ones you should do this to? So that's the line of thought one would go down. And what matters here is people not recognizing, taking to be a matter of what they think of as social forces, what are in fact open alternatives between which people should be choosing. I mean, I can express part of my own point of view in here. The thing is that one of my great pleasures in the last 24 hours is to think just how much money the investors in Twitter are going to lose. Gives me great pleasure.
We have time for one more question.
Hello, Professor. I'm Jordan Wales from the Department of Theology at Notre Dame. And for this question, I'd like to return to your remark about knowing the positions and velocities and characteristics of the particles at the inception of the universe. And I took that to be a reference to the Laplacian superscientist who can predict the final or future state of things based on knowing the current state exhaustively. And you said that such a mind would be unable to predict the emergence of natural science. But could it not be countered, and I don't take this position, but I'm curious what your response would be, could it not be countered that indeed the emergence of natural science could have been predicted by such a mind, but such a mind would not have recognized the predicted emergence as an emergence of natural science because it wouldn't have described it as such, because it would have been making this prediction as a state of particles or a state of neurological processes. And that further, there are some who don't consider this to be a deficit at all in the abilities of such a mind, because in fact, predictions such as the emergence of natural science are not meaningful predictions at all. So the professors Churchland take up this position that, that brain states and neurological processes are really all there is. And if you want to know the difference between a ballerina and a falling soccer player, you only have to look further back in the scheme of neurological processes to differentiate that, if you wish to. But that really talk about the causality of thoughts is meaningless talk, because these are just, this is a emergent mythology that we layer upon neurological processes. Now, I don't take this view, but I'm curious what your response would be.
Well, let me deal with two separate theses here that you put forward. First of all, it's perfectly clear that every state of the universe is a physical state. But for any state of the universe, no matter what is happening in it, no matter how described, this is a state which is characterizable in terms of fields, quantum fields, and the quanta that are, and the particles that are the quanta of those fields. So of course, since the emergence of natural science occurs in a particular historical period, that's a state in which the universe is in a physical state, and somebody could have predicted that particular physical state. What they wouldn't have known from their knowledge of physics was that this was the emergence of natural science. So in an important way, they wouldn't have been able to predict it. That's the answer to the first thing you said. Secondly, what you've said about the Churchlands just ain't true. And this requires, I mean, quite a lot of experience. The Churchlands are immensely more sophisticated than you suggest, and they don't even, Patricia Churchland and Paul Churchland aren't necessarily to be put together in this way. It is true that the Churchlands believe that our ordinary language of intention, purpose, reason, and the like needs to be replaced by a language in which we treat ourselves seriously as brains. But then you have to ask, what is the conception of being such an agent for the Churchlands? And it's not a bit as you describe it. I think, or not a bit goes perhaps a little far, but actually they hold a view that is not that is often misrepresented in this way. It's a great mistake to suppose that a naturalistic or materialistic view of this kind cannot be enormously sophisticated. It is, in their case.
Thank you.
Thank you all for coming. I'd like to invite you to browse the book selections in the room across the hall from the auditorium, and please join me in thanking Professor MacIntyre.